Hello guys and welcome to your video lecture all about matter. So yesterday we finished up our unit on bioenergy. You should have taken your exam already. This is your little push if you haven't taken that exam. Now is your time. Don't get behind. We're starting a new quarter. Let's start off on the right foot. We're going to be entering our last unit of the semester today. It's all about matter or chemistry. Before we can learn too much about chemistry, though, we've got to know what matter is. That's what the point of this lecture is. You're going to use this lecture to fill out the video notes or the guided notes, and then you'll turn those in at the end of this. Before we start, though, which of these items is made out of matter? You've got glasses, a person, a butterfly, a computer, coffee, desk, chair, plant, cat, cloud, sun. You could even say the window, the shoes, the clothes. You could get more specific to the water in the plant. Hopefully you were able to tell me that every single thing is made out of matter. Just a reminder, matter is anything that has mass and takes up space. So everything you see and interact with is in fact matter. Again, matter is anything that has mass and takes up space. All matter is made up of atoms. We call atoms the building blocks of matter because we use the atoms to make up all matter. Atoms are the tiniest particles of an element that cannot be broken down any further. That means that if I were to try and karate chop, if I were to try to chop up, say, an orange or something, and I got to the teeny tiniest piece, that still wouldn't be what I could see, wouldn't be an atom. I would have to go microscopic, and even then, I wouldn't be able to see the atom. Atoms are very, 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 very tiny. Generally, or not generally, but when we have one atom, it is made up of an element. So we have many different kinds of atoms, but we can't break that atom into anything smaller without it losing its function. So I could break it down into an atom if I had the means, but once I tried to break it even further, my atom would break and it would no longer be able to do its original function. When we separate things out into atoms, we say that they are made up of elements, like our periodic table, which we're going to study later on after spring break. Atoms and elements. An element is a pure substance that cannot be broken down into any other substance. It's pure. So if you are a highlighter or a starer, I would make sure that pure is highlighted. Our elements are what we find on the periodic table, like hydrogen, oxygen. You could have metals like iron or copper. We've also got some of our more rare elements like pluton and perhaps uranium. Each element is made out of one type of atom, so I could have a bunch of different atoms together and they could still be an element as long as they were made of the same type of atom. For example, carbon is an element on the periodic table of elements. It's made up of only one type of atom, carbon atoms. Later, we'll get into distinguishing between molecules and compounds. Molecules and compounds are made up of multiple types of elements. Atoms and elements continued. Carbon atoms make up the element carbon. The element carbon is only made up of carbon atoms. There are no other types of atoms in the element carbon besides carbon atoms. That means that if I were to find pure carbon, it would only be made out of carbon atoms. I want you to think of like a salad with just lettuce. So we don't have any tomatoes in it, we don't have any salad dressing, it's just lettuce. Or perhaps maybe a bowl of cereal. If you've got Cheerios, you've only got Cheerios in it. You don't have any Golden Grahams or Fruit Loops in it, it's just Cheerios. All atoms are not the same. all atoms of the same element have the same properties because they're like clones of each other. For example, all oxygen atoms have the same mass and occupy the same amount of space. Therefore, all matter made up of oxygen has the same properties because of the oxygen atoms that make it up. Properties are how an atom or element will react with one another. So are they very reactive? Are they going to explode? What do they commonly bind with? How electronegative are they? What kind of bonds do they make? Those are all properties. So if I have two oxygen atoms, they're going to act the same. They're going to look the same. They'll look like clones. However, oxygen atoms have different properties than iron atoms, carbon atoms, or nitrogen atoms, or any other type of atom. So my oxygen atom is not going to act like my iron atom, and my iron atom isn't going to act like my carbon atom because they're different elements. They have different properties. For example, iron atoms react quite strongly with oxygen. Iron atoms will rust when oxygen interacts with it. Carbon atoms, on the other hand, don't rust when they interact with oxygen. Sometimes they'll bond and become carbon dioxide. Sometimes they can also form alcohols, which is a group on a molecule, not the alcohol you drink. Atomic structure. Atoms are made up of subatomic particles. That's a big word, but it's one I want you to add into your vocabulary. Sub means smaller part of an atom, because we have atomic in there. So smaller parts of my atom. These subatomic particles include protons, neutrons, and electrons. Protons and neutrons are found inside the nucleus or center of the atom. Electrons are found outside the nucleus in what we call the electron cloud. They do not look like these spinning rings right here. They actually look more like the electron clouds. They don't look like the spinning ring. They actually look more like a balloon that comes off the nucleus. We will look more into that, though, on Thursday. Recall, so hopefully you've learned this before, but protons have a really large mass. That's why they're congregated, so they're, quote, heavier. They take up more space. That's why they're congregated in the middle of my nucleus. And they have a positive charge. My neutrons also have a very large mass. That is why they're also found inside the nucleus. They have no charge. They are neutral. And then my electrons have virtually no mass. They have a little bit of mass, but it's nothing compared to the protons or neutrons. So, excuse me. That is why they flow outside of the atom in what we call the electron cloud. Electrons are negatively charged. So this is something we're going to go over again when we study the periodic table, but let's introduce you to it now. How to find each of our numbers here, the number of protons we can find by knowing the atomic number of the element. For example, hydrogen's atomic number is 1. That means that in the nucleus of its atom, it has just 1 proton. In contrast, helium's atomic number is 2. That means that it has 2 protons in the nucleus of the atom. Our number of electrons, this changes a little bit depending on if my atom bonds, but for the purposes of this lecture, and until we discuss bonding, the number of electrons is equal to the number of protons. This is the atomic number again. So for hydrogen, which I said has an atomic number of 1 and has 1 proton, hydrogen, if neutral, would have 1 electron. Helium would have 2 because helium has an atomic number of 2. The number of neutrons can be found by subtracting the mass number from the atomic number, because we said electrons are virtually unmassive, so we don't really contribute them to the weight of the atom. So if we take the mass number minus the atomic number, because the atomic number equals our protons here, we are going to be able to find out how many neutrons we have. Fantastic. So if we were looking at a periodic table, and again, we're going to go through this another time, but our protons are found in the atomic number. So for copper, my atomic number is 29, so you know that copper has 29 protons. And the proton number will never change no matter how my atom bonds to one another. When I change my number of protons, I'm changing the element altogether. The other number on this periodic table cut out is the mass number. The mass number, remember, is the number of protons plus the number of neutrons. We don't include electrons because they're not very massive. So if I wanted to find out the number of neutrons, I would know the number of protons, which is 29, plus neutrons equals 63.55. So if I subtracted 63.55, or 29 minus 63.55, that number would be my number of neutrons. You could do the same thing with tellurium here, but we'll practice that another day. I do want you to get familiar with the periodic table. For example, right here, you've got the atomic numbers, and they go in order if you notice. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, and so on and so forth. So as you read the periodic table like you would read a book from left to right, we are increasing the number of protons. There are 92 naturally occurring elements found on the periodic table of elements, which is what you're looking at right here, along with many man-made elements. Here is how we separate the periodic table. We are going to look at this again though, so I don't want you to pay too much attention to this. I do want you to realize though and notice that we separate our periodic table into 3 categories: nonmetals, metals, and metalloids. The metalloids happen right here in blue. Usually we draw a diagonal line right here, and anything below the diagonal line is considered a metalloid, which means that they have similar properties to both nonmetals and metals. Our green here is our metals, and our yellow is our nonmetals. There are 3 stages of matter, and this is actually what we're going to study tomorrow. There's three stages of matter, are something that you've heard before, especially since we've already studied the water cycle: solid, liquid, and gas. A solid is matter that has a definite volume and a definite shape. A liquid is matter that has a definite volume but no definite shape. No matter where you put your liquid, it's going to be the same volume as long as you dump all of it out. But the shape's going to change depending on the container, because a liquid takes the shape of any container it's in. A gas is a matter that has no definite volume or shape. A gas spreads out to fill its container. A matter of mass. All things don't contain the same amount of matter. Mass is how we measure how much of matter is in something. So when I say that I have taken the mass of something, I'm not saying the weight. I am determining how much matter is in that object. It's something we generally do with a scale. Matter also takes up space, meaning that the amount of space that matter takes up is called volume. Think about the chalk dust on a chalkboard. Does it have mass? Volume? Yes. Is it the same amount as a piece of chalk? Nope. We'll have to finish the rest of these in a minute. All right, I'm going to flash the slides to you because these have been reviewed, so pause it and take down your